Hello, this is another video on sequence and series. In this video, we are going to look at some examples. So let's look at the first one. The first term of an arithmetic progression is 7, and its fifth term is 23. Find it should be 8. And its fifth term is 23. We have to find the common difference. It's 15th term and the sum of the first 10 terms. So what do? And let's list what we have. From the question, we know they were given the first term, A, that's 7, and the fifth term is 23. So we know that for an arithmetic progression, AP, there will be a common difference, D. So we are not given the common difference here, but we know that the fifth term can be written as A plus 4D. You remember the nth term, A plus n minus 1D. So when n is 5, it means that if we put 5 here, you will have 4. 5 minus 1 is 4 times the 4D. So A plus 4D is the fifth term. Okay? And that fifth term, you know what it is, 23. Okay? Now, but we're given the first term A. I can replace A with 7. So 7 plus 4D equals 23. And if I move 7 to the other side, 4D will be 23 minus 7. And 4D will be 16. So if I divide both sides by 4, then D will be 4. So now I know the common difference, which is the first part of the question. Then the second part says find the 15th term. I know D as 4 and I know A as 7, and I want to find the 15th term. That means n is 15. So UN, you remember the formula for the nth term of an AP is equal to A plus n minus 1D. Okay, so U15, because n is 15, equals A7 plus 15 minus 1 times 4, which is D. So U15 will be 7 plus 14 into 4. So, and U15 will be 7 plus 10 times 4 is 56. So U15 will be 56 plus 7. That should give us 63. So that's the 15th term. So the next question says the sum of the first 10 terms. The sum of the first 10 terms. So here n is 10 because that's the position we're interested in this question. Sum of the first 10 terms. And then when you add from first to the 10th position, then what will be the sum you're going to obtain? We know the first 10 as 7, and we know the common difference as 4. A is 7 and D is 4. We can use the formula for sum of nth term of an AP, because here we don't know the last term. So we can use the other one, n over 2 into 2A plus n minus 1 D. Okay. So S10, the sum of the first 10 terms will be 10 over 2 into 2 into 7 plus n is 10, 10 minus 1, then 4. So S10 should be, so this will give us 5, and this will be 14, plus this will give us 9 times 4. So S10 will be 5 into 14 plus 36. S10 should be 5 into 40 to 50. And S10 should be 5 times 5, 25. So I am 50. So it means when you add from the first term up to the 10th term, you will get 250. Okay? That's clear now. Then we have another example. The 7th and the 10th terms of an arithmetic series are 36 and 30. It's an arithmetic series, so that means it's going to have a common difference. We know the 7th term and we know the 10th term, 36 and 30. So we have to find the nth term. So we have to write an expression for the nth term and also find the sum of the first 5 terms. Okay. So how do we deal with this? Here we have the value for the 7th term, and we know that the 7th term can be written as a plus 60. Don't forget, because it should be n minus 1. So 7 minus 1, and that is given as 36. So the 7th term is 36, and the 10th term is 30. So 10th term should be a plus 90. That's 30. So if I call this equation 1 and I call this equation 2, means I can solve them simultaneously. If I solve them simultaneously, I can eliminate. If I subtract equation 2 from 1, then this will cancel out, and I will have minus 3d as 6d minus 9d will give me minus 3d, and 36 minus 30 will give me 6. Then I divide both sides by minus 3, and d will be minus 2. So I know the common difference as minus 2. Then I can write the expression for the nth term, because I know for an arithmetic series, the nth term, un, it will be a plus n minus 1 d. So un will be, do I know the first term? No, so I can calculate the first term using any of these equations. So, the first term is a plus, first term is a, and from equation 1, a plus 6d equals 36. So if I substitute d as minus 2, a plus 6 into minus 2 equals 36. A minus 6 times 2 is 12 equals 36. So a will be 36 plus 12. So a is 48. So the first term of that series is 48. So then I can replace a with 48 in this equation. Then plus n, I don't know what n is, because it's saying the nth term. So we don't know, we just want to write an expression because we don't know the position. Then d is minus 2. So un will be 48. If I expand this bracket, so minus 2 times n, you give me minus 2n, then minus 2 times minus 1 will give me plus 2. So that means un will be 48 plus 2 minus 2n. So un will be 50 minus 2n. So this is the expression, this is the equation for the nth term. Okay. Then we have to find the sum of the first 5 terms. The sum of the first 5 terms. So the series is an arithmetic series. So that means here n is 5 because the person says first 5 terms. Then we know a as 48 and d as minus 2. A is 48 and d is minus 2. And I can use the formula Sn because n over 2 into 2a plus n minus 1d. Then Sn, with x5 now, because I know n is 5, will be 5 over 2 into 48 plus 5 minus 1 times minus 2. Then S5 will be 5 over 2 into 48 times 2. So that will be 96. And then this will be plus 4 into minus 2. And S5 will be 5 over 2 into 96 minus 8. Then S5 should be 5 over 2 into 96 minus 8 should be 88. So 2 can cancel here, 1, 2 here, 44. So S5 will be 5 times 44, and that will give you 5 times 44, 220. So that's the sum of the first 5 terms in that series. Okay, hope that's clear enough. Now let's look at another example. In this example, you are told that the third and the fourth terms of a geometric series are 24 and 8 respectively. So we have to find the common ratio of the series. So what do we do? The third term, now we have geometric series. The third term, U3, can be written as AR raised to the power 2. You remember the formula for nth term, AR raised to the power n minus 1. Now n is 3, because it's third, the position is third, so n will be 3. So 3 minus 1 is 2, so AR raised to the power 2. Then U4, that's the fourth term, is AR raised to the power 3, because we know where n is 4, so if we put 4 here, that will be 4 minus 1, that's 3. And we know the values, the numbers that fall at those positions. For the third position is 24, so we know. And for the fourth is 8. So I have two equations now. AR raised to the power 2 equals 24, and AR raised to the power 3 equals 8. So what can I do? This is equation 1, equation 2. We want to solve them together. Remember, for AP, when we derive the equations for the different terms that we have, we solve them simultaneously. So, but here, what we can do is to divide one by the other. So because R has higher power in equation 2, I want to divide equation 2 by 1. Divide 2 by 1. So if I do that, that means I will divide the left-hand side by the left-hand side. So AR raised to the power 3 divided by AR raised to the power 2 equals, then the left-hand side, 8 divided by 24. So you can see, basically I have, as a numerator at the top, I have equation 2, and at the bottom, I have equation 1. Okay, so A can cancel A, then this will give me R. Remember law of indices, R3 divided by R raised to the power 2 would be R raised to the power 3 minus 2, which is R raised to the power 1. So R equals, then 8 here 1, 8 here 3. So the common ratio is 1/3. Then that's the first part of the question. The second part says find the first term of the series. So how do I get A? I can substitute the value of R into any of these equations. So if I use equation 2, then A R raised to the power 3 equals 8. So A R is 1/3 raised to the power 3 equals 8. So A into 1/1 raised to the power 3 is 1. 3 raised to the power 3 is 27 equals 8. So this will give me A/27 equals 8. Put over 1, then cross multiply. Means A will be 27 times 8. And A will be 216. Okay, so that's the first thing. Then you have to find the sum of the first 11 terms of the series. The sum of the first 11 terms. So this, in this case, n is 11, third part, and we know so 11 terms, so n is 11. We've calculated the first term as 216, A 216, and the R common ratio is 1/3. So if you recall the formula for the sum of nth term of a geometric progression, that's A into 1 minus R raised to the power n divided by 1 minus R. So S11 will be A is 216 into 1 minus 1 over 3 raised to power 11, then divided by 1 minus 1 over 3. So S11 will be 216 into 1 minus 1 over 3 raised to power 11. So that will give you very small number, 0.00005, 645. 1, 2, 3, 4, 5. Then all over. This will give you 2 over 3. Huh? Then 1 minus that, 0.999. Then multiply by 216. That's 215.9. So S11 will be, because that will be approximately 216 also, because we can sum this. You can approximate this as 1. So let me just approximate that, then divided by 2 over 3. So that will be 216 times 3 over 2. 216 over 2. So that will give you 324. So it's approximately that. Okay. So that's it for this video, and I'll see you in the next. Bye-bye.